Welcome to our presentation on the evolution of wide research AI agents. AI agents are autonomous systems that perceive their environment, learn, and act to achieve specific goals. Unlike simpler AI systems, they can manage complex, multi-step workflows with highly variable inputs and outputs. Wide research AI agents are specifically designed for broad, in-depth research across various domains. They leverage tools like web searches, literature reviews, and data analysis to enhance human research capabilities, enabling faster and more comprehensive exploration. These agents have the potential to transform industries such as healthcare, finance, and retail by increasing productivity and automating labor-intensive tasks. Their autonomous operation allows them to handle complex workflows that were previously difficult to automate efficiently. As we explore the evolution of these remarkable systems, we'll see how they've developed from theoretical concepts to the sophisticated tools that are reshaping research and innovation today. The journey of AI agents began in the 1970s and 1980s with early work on distributed artificial intelligence, which laid the groundwork for agent-based systems. By the 1990s, more formal definitions emerged. Russell and Norvig defined AI agents as systems that perceive through sensors and act via actuators, establishing the perception-action loop that remains fundamental to agent design today. Around the same time, Wooldridge and Jennings proposed key properties that define agents: autonomy, social ability, reactivity, and proactivity. Early examples of these concepts included ELIZA, developed in 1966, which was an early chatbot using simple pattern matching. Another notable example was Mason, an expert system designed for medical diagnosis that could reason through medical problems using a knowledge base. These early concepts established AI agents as autonomous, goal-oriented systems, setting the stage for the more sophisticated developments that would follow in subsequent decades. While primitive by today's standards, these early systems demonstrated the potential for machines to act independently towards specific objectives. In the 2000s to 2010s, AI agent development focused on cognitive architectures and rationality, bringing more sophisticated reasoning capabilities to these systems. Cognitive architectures like ACTR, introduced in 2004, integrated theories for perception, memory, reasoning, and learning into unified frameworks. Similarly, SOAR further developed in 2012 and provided another comprehensive framework for agent cognition, with a particular focus on problem-solving mechanisms. Rationality became a central design principle during this period. Russell and Norvig emphasized rationality as achieving the best or expected best outcomes, which guided decision-theoretic agent design. This focus on rational decision-making remains influential in modern AI agent development. Key developments during this era included the introduction of advanced machine learning techniques, particularly reinforcement learning methods like temporal difference learning. A landmark achievement was Deep Blue's victory over world chess champion Garry Kasparov in 1997, demonstrating advanced decision-making capabilities in a specialized domain. These developments were crucial as they enabled agents to reason, make decisions effectively, capabilities that will become essential for research-oriented tasks in the future. The period from 2017 to 2023 saw revolutionary advancements in language models that dramatically transformed AI agent capabilities. In 2017, Cristiano and colleagues introduced reinforcement learning from human feedback, or RLHF. This technique aligned agent behavior with human preferences, significantly enhancing autonomy and making AI systems more useful and reliable. A major breakthrough came in 2020 with GPT-3, which demonstrated remarkable emergent capabilities and influenced foundation models for agent cognition. The ability of these large language models to understand context, generate coherent text, and perform reasoning tasks opened new possibilities for AI agents. By 2023, advanced models like GPT-4, Claude, and Gemini further expanded reasoning and task-handling capabilities. These models could understand nuanced instructions, maintain longer context, and perform complex multi-step reasoning. The impact on research was profound. LLMs enabled natural language understanding and generation, which proved critical for synthesizing information and generating hypotheses. This allowed AI agents to process and produce human-like text, making them valuable tools for research and knowledge work. These language models became the backbone of modern AI agents, enabling them to tackle complex research tasks that were previously impossible. AI agents are making significant impacts across multiple industries, with specialized applications tailored to each sector's unique needs. In healthcare, AI agents are revolutionizing drug discovery and treatment development. They're being used for drug repurposing, identifying existing medications that could treat new conditions. They're also accelerating target discovery for new treatments and performing comprehensive medical literature analysis and synthesis that would take human researchers months to complete. The finance industry is leveraging AI agents for market research and trend analysis, helping firms stay ahead of market movements. Investment analysis and portfolio optimization are being enhanced by agents that can process vast amounts of financial data. Additionally, fraud detection and risk assessment have become more sophisticated with AI agents that can identify patterns indicative of fraudulent activity. In retail, AI agents are creating personalized consumer experiences by analyzing shopping patterns and preferences. They're optimizing supply chains by predicting demand and identifying potential disruptions. Market research and competitive analysis are also being transformed, with agents continuously monitoring competitor activities and market trends. Software development has seen the emergence of autonomous software engineers like Devin, introduced by Cognition Software in March 2024. These systems can perform programming jobs unassisted, though current accuracy still requires human oversight. In a recent benchmarking test, Devin resolved nearly 14% of GitHub issues from real-world code repositories, twice as effective as LLM-based chatbots, but still demonstrating the need for continued development. AI agents are making significant impacts across multiple industries, with specialized applications tailored to each sector's unique needs. In healthcare, AI agents are revolutionizing drug discovery and treatment development. They're being used for drug repurposing, identifying existing medications that could treat new conditions. They're also accelerating target discovery for new treatments and performing comprehensive medical literature analysis and synthesis that would take human researchers months to complete. The finance industry is leveraging AI agents for market research and trend analysis, helping firms stay ahead of market movements. Investment analysis and portfolio optimization are being enhanced by agents that can process vast amounts of financial data. Additionally, fraud detection and risk assessment have become more sophisticated with AI agents that can identify patterns indicative of fraudulent activity. In retail, AI agents are creating personalized consumer experiences by analyzing shopping patterns and preferences. They're optimizing supply chains by predicting demand and identifying potential disruptions. Market research and competitive analysis are also being transformed, with agents continuously monitoring competitor activities and market trends. Software development has seen the emergence of autonomous software engineers like Devin, introduced by Cognition Software in March 2024. These systems can perform programming jobs unassisted, though current accuracy still requires human oversight. In a recent benchmarking test, Devin resolved nearly 14% of GitHub issues from real-world code repositories, twice as effective as LLM-based chatbots, but still demonstrating the need for continued development. Let's examine a leading example of wide research AI agents in action, the AI Co-Scientist developed by Google Research. This system represents the cutting edge of AI agent technology applied to scientific research. The AI Co-Scientist is designed to generate novel research hypotheses, create detailed research overviews, and develop experimental protocols. What makes this system particularly powerful is its use of specialized agents working together. These include generation agents that create new ideas, reflection agents that evaluate those ideas, ranking agents that prioritize the most promising directions, evolution agents that refine hypotheses, proximity agents that identify related concepts, and meta review agents that provide overall assessment. The AI Co-Scientist has demonstrated impressive results across multiple scientific domains. In drug repurposing for acute myeloid leukemia, it proposed novel candidate treatments that were subsequently validated in laboratory tests. For liver fibrosis research, it identified epigenetic targets with antifibrotic activity that researchers might have overlooked. The system's effectiveness has been validated through rigorous evaluation. It outperformed other models using the ILO auto-evaluation metric and, perhaps more importantly, was preferred by domain experts for the novelty and impact of its contributions. This case study demonstrates the transformative potential of wide research AI agents in accelerating scientific discovery. As we've seen throughout this presentation, the evolution of AI agents has been remarkable, progressing from theoretical concepts in the 1970s to the sophisticated autonomous systems we see today. Looking at the timeline of this evolution, we can trace the development from theoretical foundations in the 1970s to 1990s through cognitive architectures in the 2000s to 2010s, to the revolutionary language models of 2017 to 2023, and finally to the agentic AI systems of today and tomorrow. Wide research AI agents have proven particularly valuable in enhancing human research capabilities. They enable faster and more comprehensive exploration across domains, accelerating scientific discovery and innovation in ways that were previously impossible. The future outlook for AI agents is extremely promising. Continued advancements will lead to more autonomous, collaborative AI systems, with parallel processing capabilities like Manus Wide Research deploying 100+ agents simultaneously to tackle complex tasks at unprecedented scale. These developments will further revolutionize research and knowledge work across industries. However, as these systems become more powerful, our call to action becomes more urgent. Stakeholders must address ethical challenges to responsibly leverage these systems, ensuring transparency, accountability, and alignment with human values. The governance frameworks we establish today will shape how AI agents develop and integrate into society in the coming years. The evolution of wide research AI agents represents one of the most significant technological developments of our time, one that will continue to transform how we work, discover, and innovate for years to come.